I am Loganayaki, TK, Assistant Professor, Department of Mathematics from M.O.P. Vaishnav College for Women. Today's topic is sequence of real numbers from the course Real Analysis. So, what is a sequence? A sequence is generally defined as the list of numbers with this specific pattern, right. So, here the list of numbers means either it can be the finite sequence or the infinite sequence. The list may be finite or infinite, but the sequence can be infinite. Generally, we denote the sequence as the sequence an in parentheses or in the brackets. So, an denotes the first term, a2 is the second term, an is the nth term. So, an plus 1 is the n plus 1th term of the sequence. So, normally we should not confuse with an plus 1, that is the n plus 1th term of the sequence, and the sum of an plus 1, that is the sum of the nth term and plus 1. So, we should be very careful with the subscript plus 1, that should not migrate out of the subscript. So, example of the sequence an, the first example is an equal to n, which is the infinite sequence, and an equal to minus 1 the whole power n is the alternate sequence. Now, we can visualize the sequence and the pattern. So, we can see here the figure number on the purple, which is a triangle. The figure 1 contains the 4 triangles and figure 2 contains the 8 triangles, figure 3 contains the 12 triangles and figure 4 contains the 16 triangles. So, it follows the triangles, the number of triangles on the figures follows a pattern of plus 4. So, anyone can predict what will be in the figure 5. So, what is in the figure, what will be in figure 5? Figure 5 will be 20 triangles. So, it forms a pattern that t equal to 4n. So, what is t? T is nothing but the general sequence. So, an which is nothing but 4n. Graph of a sequence. Now, we can see the sequences. So, the first sequence, that is the first term of a sequence is 1 comma 2, 2 comma 3 by 4 and 3 comma 4 by 9. Here the first number denotes the number of terms of a sequence, that is the first term, second term, third term, and the second term, second number, that is the value of the sequence, that is 2, 3 by 4, 4 by 9, 5 by 16. So, what will be the nth term of the sequence? So, the nth term of the sequence follows a pattern. What is the pattern? The numerator is nothing but, if it is the second term, that is numerator is 3 and denominator is square of the term. So, 2 square which is 4. Similarly, we go to the third term. So, numerator is nothing but n plus 1, 3 plus 1 divided by the square of the term, which is 3 square 9. So, easily we can predict what will be the nth term of the sequence a n plus 1, which is n plus 1 divided by n square. So, if the sequence goes in the proceeding in this way, where the sequence stops, right. So, we can see the pattern here if it is n equal to 1. So, easily it is represented in the graph when n equal to 1, so value is 2, right. When n equal to 2, so this is a non-increasing sequence or the decreasing sequence. So, when n equal to 2, the value is 3 by 4, when n equal to 3, the value is 4 by 9, it is a non-increasing sequence, or we can say it is a decreasing sequence. At some point of time, it approaches the value 0. So, the value of the sequence, that is nth value, which when n tends to infinity, when n approaches the infinite number, the value is 0. So, that is called as the limit of the sequence. So, this graph leads us to an important idea about the sequences. What is that? As n increases, right, the sequence gets closer to 0, we call this as a limiting point or the limit of a sequence. So, limit n tends to infinity, a n equal to n plus 1 divided by n square, the value is 0. Next, we move to the limit of a sequence formal definition. So, how we define mathematically? We have seen the problem from the example, we have seen what is the limit of the particular sequence n plus 1 divided by n square. Now, we see the limit of formal definition of a sequence, that is that L belongs to a real number. What is R? R is a real number and L is the limit of the any sequence when n approaches infinity. So, as n tends to infinity, with the sequence as the limit, that is denoted by L. So, the definition is for epsilon given greater than 0, that is given epsilon greater than 0, there exists a natural numbers n belongs to n such that sequence modulus of a n minus L is less than epsilon for all n greater than or equal to capital N. So, this is the definition of the convergence of a sequence. Now, we move to the convergent sequence. If any sequence has the limit, then we can say the sequence is convergent. So, the definition is nothing but a sequence a n is said to be convergent if there exists a finite real number L such that limit n tends to infinity a n equal to L. If there no such L exists, then the sequence is a divergent sequence. Now, we move to the example of the convergent sequence, which is a trivial example in this sequence of real numbers is 1 by 9. So, let a n equal to 1 by n equal tends to infinity. If we substitute n tends to infinity, a n will be equal to 0. The sequence 1 by n converges to the limit 0. Similarly, next is the, if it is a convergent, next we will move to the divergent sequence. A sequence is divergent if it does not have a limit or the sequence is not convergent. Another one, it is a oscillating sequence. Suppose we take the sequence minus 1 whole power n. So, what are the terms of the sequence? The terms of the sequence will be minus 1, 1, minus 1 and 1. It is alternative. So, alternative of minus 1 and plus 1. So, there is no single limit for this sequence, either it should be minus 1 or it approaches to 1. So, the uniqueness of the limit should be there for the convergent of the sequence. There is no uniqueness of the limit, then it is a divergent sequence. So, oscillating sequence is also divergent. Uniqueness of the limit. So, as already discussed, the limit of the sequence should be unique if the sequence is a convergent sequence. So, we have the theorem on this called as the uniqueness of the limits. Suppose the sequence a n has the two limits L1 and L2. So, how will you prove this? This uniqueness is, the limit is unique. Suppose the limit a n equal to L1, by the definition we will write that as for n greater than n1, modulus of a n is less than epsilon. Similarly, if a n has the limit L2, we write as modulus of a n minus L2 is less than epsilon. So, let we choose n is the maximum of n1 comma n2, we have modulus of L1 minus L2, we substitute both the limits, it will be less than or equal to modulus of L1 minus a n plus modulus of a n minus L2. By modulus property, it will be less than or equal to modulus of L1 minus modulus of L2, which is a contradiction to our assumption. So, the limit of this sequence should be unique. So, formal definition of a bounded sequence, next is a bounded sequence. So, what is the sequence a n is bounded if there exists a real number? From you can choose any real number from the sequence. Suppose the sequence is 1 minus 1, 2 minus 2. So, the absolute value will be 1 and 2 and 3. It does not contain the sign positive or the negative. So, what is a bounded sequence? The bounded sequence of real numbers is defined by modulus of a n is less than or equal to k. So, k is the maximum value you can choose. If you choose the modulus of the absolute value of the sequence, suppose the sequence is 1 minus 1, 2 minus 2. So, the absolute value will be 1 and 2 and 3. It does not contain the sign positive or the negative. It should be less than, it should be bounded by one number, then we can call that sequence as a bounded sequence. Next is the Cauchy sequence. So, Cauchy sequence is more or less similar to the sequence definition. So, that is, if you take instead of the limit of a sequence, it approaches to the, it is nearer to the two numbers. The two numbers approaches together. So, that is called as a Cauchy sequence. That is for a given epsilon greater than 0, right. For what is the definition of a limit of a sequence? We define the limit of the sequence as modulus of a n minus L. So, L is the limit. Instead of L, we have the term of a sequence, modulus of a n minus a m will be less than epsilon. So, example, the trivial example is nothing but 1 by n, we can take it as, so we choose 1 by 2, which is nothing but 0.55, and 1 by 3, which is nothing but 0.33. So, the difference, the closeness, so difference between is nothing but which will be less than the epsilon, which approaches to the limit 0. So, the Cauchy sequence is a convergent sequence of real number system. So, 1 by n is a Cauchy sequence. Now, we have seen the definition of a convergent sequence, divergent sequence, bounded sequence and Cauchy sequence with an example. Thank you.